Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we are going to be talking about scalar product in 2 and 3 dimensions, right? So we're going to be talking about scalar product in 2 dimensions as well as in 3 dimensions. So let's go ahead and get started. So if you've seen the previous video, we actually defined what the scalar product is. So the scalar product of two quantities, I'm just going to revise the previous video, was that if you have two vectors u and v, then the scalar product or the dot product is equal to the magnitude of u into the magnitude of v into the cosine of angle between both the vectors. This was the scalar product of two vectors. Now let's say if I break this vector further, I say vector u is made up of u1 and u2, or you can even call it u1i and u2j, right? Or I say that vector v is equal to v1 and v2, or I can even call it as v1i and v2j. Fine. So let's suppose it's actually broken down like this. Now geometrically, if I show you what this means, that means that if I say this is vector v, vector u, that means this would be vector u1i and this would be vector u1j, sorry, u2j. Fine. Similarly, if I say that this is vector v, that means this is gonna, okay, so let's suppose if I say that this is vector v, then this is gonna be v1i and this is gonna be v2j. Now what can I do here is, what I can do is I can actually multiply this and this, the dot product of this and the dot product of this and this. Now why is that? Because they are parallel to each other, and when anything is parallel to each other, the angle between them is 0 degrees, and if angle between them is 0 degrees, then cos 0 is nothing but which is actually equal to 1, which means I can say that the dot product of u and v is nothing but u1 v1 cos 0, which is 1, plus u2 v2 cos 0, which is 1. That means the dot product of two vectors is equal to u1 v1 plus u2 v2. And similarly, if it's a three-dimensional vector, then the dot product of two vectors is actually equal to u1 v1 plus u2 v2 plus u3 v3. Now this is something which happens in 3 dimensions, right? So this is something which happens in 3 dimensions. So hope you're able to understand what I'm trying to say here, guys, that in 2 dimensions, this is the dot product of 2 vectors. In 3 dimensions, this is the dot product of 3 vectors. This is something that you don't know. This is something that you do when you actually know the attributes of the vector. You know its I coordinate, its j coordinate, and if it's a 3-dimensional vector, you should know its k coordinate as well. Fine. So let's go ahead and solve a question on this, guys. So here's this question. This question over here says that find u dot b when u is equal to 2 and 3 and v is equal to -1 and -2. Well, u dot v would simply be equal to u1 v1 plus u2 v2. That is going to be 2 into -1 plus 3 into -2, which is going to be -2 and -6, which is -8. Similarly here, u is -1, 2 and -3. And v is -4, -1 and 2. Again, the dot product would be u1 v1 plus u2 v2 plus u3 v3, which is going to be -1 times -4, 2 times -1, 3 times 2, which is going to be +5, -2, and +6, which is going to be 11 minus 2. That is going to be, let me see if I've done everything correct. -1 is -4 is 4. I'm sorry, that's going to be 4. So that's my bad, right? -1 is -4 is 4. This is going to be -2 and this is going to be 6. Oops, my bad again. This is actually -6 because this is -3. Sorry. Sorry for messing this up. I'll just do this again. This one is -1 into -4 plus 2 into -1 plus -3 into 2. So this one is going to be 4, -2, and -6. That's going to be 4, -8, which is actually -4, right? So that was about this, guys. So I hope you understood this point over here, guys, that the dot product of two vectors is just u1 v1 and u2 v2, and u3 v3 if it's a 3-dimensional vector. So thank you very much for watching this video, guys. I hope you understood what I'm trying to explain here. Make sure that you give us your valuable like on this Facebook page, explore our website, and give your valuable feedback on this email address. So thank you very much for watching this, guys. I'll see you in the next one.